Hello and welcome back to another BJT transistor circuit analysis. Today we are going to review this push-pull amplifier and determine the circuit output voltage VO in relation to the input VI, which is a square wave signal. This circuit consists of one NPN transistor Q1 and one PNP transistor Q2. The base terminal of both transistors are tied together and it is connected to the VI terminal through the resistor RB. Since both transistors are supplied from the input signal, then they will remain turned off without any input signal. Now let's assume VI is at its positive peak, which is 4 volts. This will turn on the transistor Q1 since its base emitter junction gets forward biased and creates a current flowing through resistor RB, base and emitter of Q1, and through the resistor RL. At the same time, the transistor Q2 will remain off because its base emitter junction is reverse biased. Here's the simplified circuit when input voltage VI equal positive 4 volt. We can remove transistor Q2 from our analysis because it is off in this case. To determine the output voltage VO, we need to calculate the current flowing through the resistor RL. This current is the same current flowing through the emitter of the transistor Q1. To calculate the emitter current, we can write a KVL from input VI to the output VO. Here's how we write the KVL in this case. And we know that the emitter current is Let's plug the resistor values and rearrange the equation to find the base current first. Then we will have IB So emitter current will be and finally VO will be Before we continue, please subscribe to the channel if you haven't yet. Your support will help this channel to grow and encourage me to create more content. Thank you and back to the video. Now let's assume the input voltage is at its negative peak, which is -4 volts. This will put the transistor Q1 in reverse bias and transistor Q2 in forward bias. Here is the simplified circuit when the input voltage is -4 volts. As you can see here, we removed the transistor Q1 from our analysis because it will be turned off. With the same approach as above, we can first find the emitter current and then determine the output voltage VO. The only difference here is the direction of the emitter or load current. Let's write another KVL to calculate the emitter current. And again IE2. Remember, beta is 100. And by plugging the resistor values and rearranging for finding IB2 first. So IB2 will be and IE2 and finally the output voltage, which is the same as emitter voltage, is here's the overall output voltage waveform in relation to the input signal. I hope you enjoyed watching this video. I also have other videos in reviewing BJT transistor circuits, which I will put the playlist link under the video description. Please like, subscribe, and share your thoughts under the comments. Thank you for your support and see you at the next video.